you have air that's more dense and less dense? Okay, if it has a bunch of mass in it, maybe if it's like really like polluted and it's kind of hazy and cloudy, that would be more dense. If it has a bunch of humidity in it, that would be more dense. How can you make air less dense or more dense?
In the freezer.
If it's colder, is it more dense or less dense?
Less dense.
It won't change.
It's more dense. Cold air is more dense. So cold air wants to sink or rise. Cold air wants to sink. Really thick, polluted, or humid air wants to rise. It's more dense. Wants to sink. So clean air wants to rise. And hot air wants to rise. So if we could think of this as like salt water, fresh water, cold air, hot air. So cold sinks, hot rises. Alright, so I'm going to try to flip it over and see if they stay separated. As long as I don't add a bunch of energy, my system will stay stable.
It's about to fail. Oh, jinx it.
Yeah, definitely.
Yeah.
Well,
Those bubbles are
Yeah, I see that.
creating energy.
Whoa.
You see that salt though?
Whoa.
That's cool.
Oh
Nothing.
It just moved.
Oh, wow.
So literally nothing happens.
That's weird.
Except if the salt got blue or
It
turquoise.
looks exactly the same.
Yeah, just switch from one jar to the other.
That's what I'm saying.
The bottom jar.
I'm so
blue in
confused.
it, right?
So does this prove that less dense wants to stay
Yes.
up on top? More dense wants to sink. So if this is, so let's say you've got hot air and cold air, and like for some reason something is forcing this cold air to rise, or yeah. So my hand is forcing the cold air to rise right now. Something is forcing the cold air to rise, then that cold air is going to force the hot air to do what?
Go down.
It's going to force it to sink. I said it wrong, didn't I?
Yes, you do.
It's going to force, the hot air is going to force that cold air to go back down.
What happens if you shake it up?
If that cold air is forced up, it's going to be forced right back down. So that's the reason
so
we
it's kind of
have,
like a magnet. Like you put two nodes together.
kind of. But that's the reason we have wind. Okay, anytime something forces the cold air up or the hot air down, it will try to go back to the way it's supposed to be, and you'll have wind. Sometimes you have really strong winds because they're trying to go back to the way they're supposed to be. All right, questions.
What would happen if you did the salt on top and you put the carbon?
We're gonna do that one next. I'm gonna take these apart and do that next. Yeah, Kaufman.
This reminds me when like two oceans, it's regular water and salt water, and there's an actual line that
brown
separates.
Yeah, I'm sure you've all seen it. You can YouTube it, and it says where two oceans meet. One ocean is more dense, one ocean is saltier, and one ocean is less.
I've never seen it.
Okay, yeah, you can YouTube it. Where two oceans meet. Phillips.
What would happen if you did this repeatedly? Because you can tell like it's changing the water, like the salt water, and it's already mixing. So
I added a little energy and they mix. And if I do it over and over and over again, they're going to mix a little bit more, a little bit more, a little bit more.
But then it won't like then both of them translate.
Then they both end up being a solution of salt water down there. Michael?
What if you do like a whole new one, be like, one of them blue, the other one's red. You got some blue, but you got more salt and red. Would it still do the same thing?
As long as there's a difference in density, even if they both have salt in them, if there is a significant difference in density, the more dense one will sink.
I look up to the top of the salt water. It's like
What about like if you take a soda that's already thick and you turn it upside down to the bottom of the can and you puncture it and you stick like a straw down into it and then you pour honey in it? Will the honey keep the fluid in?
Does that have anything to do with differences of density and less dense things
Yeah,
rising?
because like the less dense it is,
I need a totally different color. Will this
what's
make
the
it
green?
blue and yellow make green?
Yeah. There's already green up there.
I want it totally different from the blue, so.
It started to spin when you poured it in.
That looks good.
Alright,
Oh, that
now
looks
I'm
like
gonna
that
put-
too.
Looks like a green popsicle.
That looks like a green apple.
Now I'm gonna put the salt water on top of the fresh water, and what should happen?
It should go to.
What should happen, Miller?
It'll start to flow like a lava lamp.
It should flip.
It's gonna do
Yeah,
the same
they should
thing.
try to switch spots. Because this is going to be a lot of energy. Gravity is going to be pulling this more dense, more massive one down. And do you think they're going to mix or do you think they're going to stay separate?
I don't know.
A little bit of both.
A little bit of both.
Why don't you mix?
Make sure everybody can see. You guys stand up over here like Nathan was, so you're not in anybody's way. Ooh, I poured some of the green water in there. Michael, you're maybe blocking somebody's view. Okay. All right. Here we go. All right, I'm gonna try to pull it out quick and just let this all happen at once. See.
What is green and blue like?
Purple.
Purple? Oh, you failed.
Oh, I can see the green coming down, and then I saw the blue go up, but then they mixed. It's a really fast change. You can see the green sink, but then once the blue goes up, they all mix
Hey.
together.
That looks like Kool-Aid.
Hey, look at it through the video.
Did you record it?
Oh yeah.
Wonder if we can slow motion it.
I don't think my phone has slow motion software.
No, our phones don't. They don't. Androids.
So you pulled it fast and it was just like fast reaction and just mixed it.
Yeah, if I had done it slow, it would have. You'd been able to maybe. It would have lasted longer, but it wouldn't have.
You don't mind if I put this on YouTube, do you?
I do not mind. All right.